Hello students. So today we're going to be talking about metamorphic rocks. Metamorphic rocks corresponds to chapter 2 lesson 5 in the book, and the learning target is I can describe how heat and pressure cause rocks to change to new metamorphic rocks. Now, as usual, please line up your notebook at the top and about 1.5 inches from the side margin, as we usually do with our Cornell notes. Now, metamorphic rocks, I've got a picture over here, a fossil that has been changed, that's been squished, compressed, and fossils can only form in sedimentary rock, but fossils can be squished if they're in that metamorphic rock, that sedimentary rock that is changed metamorphically. What is a metamorphic rock? Metamorphic rocks form as a result of intense heat and or pressure to another type of rock. So you start with a sedimentary rock, add intense heat and pressure, it's going to change into another type of rock, a metamorphic rock. Now, the structure and crystallization is different in metamorphic rock. It's not just the same type of rock. It's not just sandstone still that's been squished. You can't step on a piece of sandstone and say, well, it's metamorphic now because I squished it. You didn't actually squish it, you just applied pressure. You have to have some kind of physical structural change in it for it to be a metamorphic rock. Now, what's the heat source when we talk about heat being applied and changing a rock? Now, the heat source, when we talk about this, is generally going to be from the interior of the Earth, which will come from magma. Magma will heat any surrounding rock to the point where it will soften and recrystallize. The closer the rock is to the magma chamber, the more it will be metamorphosed. So this doesn't have to be, from a volcano. This could just be magma that was pushed up and left in the earth because of, the magma was rising through the layers. It intruded between some, as you can kind of see going on here. You've got some magma that started off here, and then it was pushing up in here into these layers. So that is causing the rocks around it. So these rocks, you can see that color around there. All these rocks around are going to start being changed metamorphically, and that's because you've got all that heat around it. What's the pressure source? Weight from overlying rock layers and or oceans will compress deeper layers. So you're going to have all that weight of the rock on top of it, maybe miles, pushing down. Deeper layers, why? What's going to cause that? How do we make deeper layers? Well, you've got sediment building up over long periods of time. Plate tectonics can drive layers deep into the earth. So in this picture you can see you've got this plate. This is an ocean plate, and I know we haven't done plate tectonics, pushing down. And so all these layers, they're getting squished. So this one is actually going down, pushing down deeper into the earth in deeper layers. You can see magma here getting pushed, rising up through, and so you're getting all this metamorphosis going on. You can see right here, metamorphic rock, all this bending and folding and squishing. Now, this is a nice picture of these rock layers. So you've got different types of rock layers. You have sand, mud, limey muds, which would be created by dying organisms like shells or clams, and basalt from some lava. Now, as you go deeper into the earth, you can see mud has been squished into shale or mudstone. You can see as you go deeper with sand, it creates a sandstone. If you go deeper and deeper and deeper, so right over here, limey mud, and then over here, limestone. So it gets squished into sedimentary rock. These are your sedimentary rocks. And so I'll circle those with this color, sedimentary. And then we're going to go to a certain grade, a lower grade metamorphosis. So you have right down here, you have slate, which is a compressed shale. You have marble, which is the compressed limestone, and quartzite down here, which is going to be that sandstone. That's when it's sandstone that's compressed. And so I'll circle those too. So you've got slate, you've got marble, you've got quartzite. Now, if you have a bunch of different types of rock that are getting even closer and closer to a magma chamber, as you can see right here, you've got all this section right here, this magma chamber. All this section right here is going to be, all of these rocks around in this area are going to be even more metamorphosed. So you can see the slate, this slate here is becoming schist or gneiss. You can see this marble might become even more crystallized. You can see this granite over here, which would be an intrusive rock in the first place, now is going to become even more changed into a gneiss. Here's another nice picture where you've got shale, limestone, all these different types of rocks, and you can see that as you go closer to the igneous rock closer to the magma chamber, you're going to have those different types of rocks forming. Texture and foliation, what does that mean? So what does this have to do with it? Texture and foliation, so you have different types of textures. Foliated rock, thin flat layering on metamorphic rocks. Examples here would be slate or gneiss. Now this is an example of gneiss, and you guys can see right there you've got these bands, and this is called gneissic banding. And that's caused because of recrystallization and pressure. Here's a video. You can actually see these crystals forming. So if you're watching this, you can see this is diorite, and it's actually going to be squished as you go down. You're seeing this squishing down and compression. And this is going to make this rock go down into this rock. So we're saying we squish everything, it's going to become that new kind of rock. Non-foliated rocks are just rocks without layering or patterns in mineral grains. Examples would be marble or quartzite. There's no pattern going on. You don't see any striping. It's just kind of random. Now, these last questions are what I want you to finish with. What are the sources of intense heat and pressure that change or metamorphose rock? What is foliation? How does it affect texture? And what are some common uses for metamorphic rocks? You can find these in the notes, your text, and maybe even the internet if you want to look some up. But try to think about these. These would be the ones you want to end with and know by the end for the test. Good luck. Let me know if you have any questions.